Hi, I'm Rob. Welcome to Math Antics. By now you probably know that math involves a lot of calculations using arithmetic, but math is about more than just calculations. In fact, one important type of math that sometimes gets overlooked involves number patterns. Now when you hear the word pattern, you might think of a shirt. Yep, and I'll bet you wish you had some fine threads like these, don't you? Oh, actually I'm good with this shirt, thanks. I get it. Not everyone can pull off a look this rad. That's true. Of course, the reason you might think of a shirt is because the word pattern often describes repeating images or objects. Like if I show you this pattern, dog, cat, bird, dog, cat, blank. What animal do you think should fill in the blank to complete the pattern? A bunny! Why would you think it was a bunny? Well, because I like bunnies. Well, it's not a bunny. It's a bird. See how the pattern repeats? Dog, cat, bird, dog, cat, bird. Well, Mr. Whiskers and I prefer the pattern dog, cat, bunny, dog, cat, bunny. Anyway, number patterns can be formed by repeating numbers, like this, 147, 147. Notice how the order of the pattern really matters? If you switch any of the numbers, it becomes a different pattern. In math, when you have a set of numbers or elements where the order matters, it's called a sequence. For example, the sequence 1, 2, 3 is different than the sequence 3, 2, 1, even though they each contain the same set of numbers. And in math, the word set refers to a group of numbers or elements where the order doesn't matter, and where any duplicates are left out. For example, if you had the sequence 1, 2, 3, 3, 2, 1, the set of numbers in that sequence is just 1, 2, 3, even though each number occurred twice in the sequence. Both sets and sequences use the same notation in math. Each number or element is separated by a comma, and the whole group is put inside curly braces, like this. Some sequences of numbers repeat, like the sequence 0, 1, 0, 1, 0, 1, but some don't repeat, like the sequence 1, 2, 3, 4, 5, 6. But think about both of those sequences for a second. Right now, each of them contains a limited or finite number of elements. They each have 6. But each of these sequences could be continued forever if we wanted to. We could just keep repeating 0, 1, 0, 1 forever. Or we could just keep counting 7, 8, 9, 10 forever too. In other words, sequences can be finite or they can be infinite. If a sequence or set is finite, it means that you can say there are a specific number of elements in it, like 6 or 20 or 1,000,000. But when something is infinite, it means that no matter how much time you have, you could never finish counting how many elements are in it. You can't give it a specific number, so you just say it goes on forever. Of course, we can't actually write numbers forever on a piece of paper, so we need to use a special notation for infinite sets or infinite sequences. You just put 3 dots at the end of the list to show that it keeps on going forever, like this. The 3 dots are an abbreviation that means the sequence continues in the same way. They can be used in the middle of a sequence to save writing. Like this means the sequence of all counting numbers from 1 to 100. But you can also use them at the end of a sequence to show that it goes on forever. So, this sequence is repeating and finite because it has just 6 elements. This sequence is non-repeating and finite because it also has just 6 elements. This sequence is repeating and infinite. And this sequence is non-repeating and infinite. Make sense? For these last 2 infinite sequences, what's the set of numbers that each contains? Well, the first keeps on repeating 2 numbers forever. So even though the sequence is infinite, the set it uses is finite because it only contains 0 and 1. But in the second infinite sequence, none of the elements are ever repeated. So the set of numbers is exactly the same as the sequence itself. It's also infinite. Okay, so now you know that some number patterns are repeating and some aren't. You also know that some number patterns are finite and some are infinite. We got our first non-repeating infinite sequence simply by counting. Let's see if we can think of some others that way too. Suppose you start counting at the number 1, but then skip every other number. You'd end up with the sequence 1, 3, 5, 7, 9, and so on. In other words, you'd end up with the infinite, non-repeating sequence that we call odd numbers, because none divide evenly by 2. Or suppose you start counting at the number 2 instead, but still skip every other number. You'd end up with the sequence 2, 4, 6, 8, 10, and so on. That's the infinite, non-repeating sequence of numbers we call even numbers, because all divide evenly by 2. And you can make other sequences by skip counting by different amounts. Like you could start with 0 and skip every 2 numbers to get the sequence 0, 3, 6, 9,